time correlation between the eruptions of Mount Vesuvius and strong earthquakes throughout Italy. In this section, the times of occurrence of Vesuvius eruptions, V equals, V1, V and V, and those of strong earthquakes in Italy, E equals, E1, ENA are compared to assess their time correlation. There are different techniques to perform the task. One possibility, if the number of events sufficiently large, is to compare the histograms representing the time distribution of the events. The period of observation, start, to end, is subdivided in moons of equal width delta ton. The analysis is performed for the two time series tin equals, x1, x and b, and y equals, y1, y, where Shanji are the number of eruptions and earthquakes in the ith time bin, respectively. The degree of correlation can be assessed parametrically, using Pearson correlation, which assumes a bivariate normal distribution of data, or non-parametrically, using either Kendall or Spearman rank correlation, which are independent on the type of data distribution. A more flexible way to represent and compare two-time distributions of events, useful even in the case they are rare, looks at their smooth time density obtained by Gaussian kernel estimation. The correlation coefficient, Pearson, Kendall or Spearman, is computed for the two functions, where phi, z, h, is the kernel function, 0 mean normal density function ends with standard deviation h, and is the smoothing parameter. The larger h, the larger the degree of smoothing. Both approaches suffer a common limitation: their results depend on the time resolution adopted for the analysis, i.e., the width of the bin for the histogram, the smoothing parameter for kernel density estimation. In general, a large time window could lead to similar flat distributions and then to a spurious high correlation. A partial solution is to perform a sensitivity analysis, checking how the value of the correlation coefficient varies for different time resolutions. A totally different approach is that based on the bivariate, Ripley's K function simplified for one dimension. It works directly on the two sets of event times, avoiding any transformation and arbitrary choice of parameters and consequent loss of information. The K function is a function of time with equation. Where I is the identity function, it returns 1 if its argument is true, 0 otherwise, and is the total period of observation in years. The K function is transformed to obtain the L function. The L function is associated with a 95% confidence envelope computed using randomizations of Van En equals 1000 in the present analysis. If, for given t, LVE, t is larger than the confidence envelope, then the number of couples for which vertical bar vi minus inch vertical bar 20 ma, toward Western Islands, 20 ma, toward Western Islands,